Hey televisions, back with me again. I'm Jagadan Putada. I'm a lecturer for parallel and distributed systems. This is our 10th meeting about parallel programming design. In our 5th video, we are going to discuss about synchronization. So here we are again in this list, and from this list we have discussed understanding the problem, partitioning, and communication. And now we are in the discussion about synchronization. What is synchronization? Synchronization is uh, the timing of two different cores. For example, now we want to compare no synchronization and synchronization. For example, we have two cores, A and B. No synchronization means that, for example, this is the finish line of the process of A and B. No synchronization just means that if A and B doesn't need to consider each other to reach the finish line. So here they can all just race to the finish line and no worries. And in synchronization, for example, there is A and B, and this is the finish line. There needs to be timing consideration. For example, A needs to at some point needs to wait for B. So A here holds their process until B reaches the same point. And when A and B has reached the same point, they continue to finish and to continue their process until the finish. So more detail about synchronization. This is three types of synchronization. There is barrier, there is lock semaphore, and there is synchronous communication. So what is barrier? Barrier is just like what I said before. For example, there is process A and there is process B. At some time, A needs to wait for B to continue with its operation, so there they create a barrier. So when A reaches the barrier, A needs to stop first, just until B reaches the same point of the progress of the program, and then they can continue to finish line. But barrier usually can be solved by the two other options, which is semaphore and synchronous communication. So what is log semaphore? I think you have learned this in operating systems. This is also a type of synchronization. What does it mean? Here, for example, we have an array that has 4 members, and here we have a pointer which points to which of the arrays needs to be filled, and we have the producer which fills the array, and we have the consumer. And the producer has two tasks. It first needs to produce, and then it fills the array. So there is a fill process, and then it increments the pointer. So here we have a task that cannot be divided, which is fill and increment, because if fill is then interrupted by consume, here consume does decrement, and then it takes. So when it fills an increment, the pointer should move to here, but if it is interrupted here, it fills and then it decrements, so it goes from here but not from here to here, not from here to here, but from here to below. So the next fill process will fill the wrong place. So here this needs to be locked, and then there's an unlock process, and also here it needs to be locked, and there is also an unlock process. So that is synchronization between two different processes with lock semaphore. And the last is synchronization. For example, there is an average process that is divided between three different cores, average A, B, and C, and then it is gathered to be calculated the average total. So here, in the last process, average total will receive from the other cores. So here, communication happens, receive, and receive. And of course, when the average total is calculated, average total needs to wait for all of them from A, B, and C. It cannot only be from A and B and then it calculates average total. So when it receive, it's called blocked receive. Blocked receive means that if not all of them are gathered, it won't continue to the next process, which is averaging total. So here, communication synchronization is doing a block receive or block send, so synchronization can happen. And so that is the end of video 5. In this video, we have successfully discussed about synchronization. In the next video, we have more to discuss. Thank you for your attention. I'll meet you in the next video.